Assalamualaikum warahmatullahi wabarakatuh. My name is Nelisa Nushafira binti Muhammad Usli. Today, I would like to explain about very high temperature reactor, which is VHTR. Okay, this is the table of content that contained in my presentation. First, what is simple nuclear reactor? Second, what is VHTR? Third, nuclear reactor design. Fourth, type of reactor core. Fifth, how does VHTR work? 6. Advantages of VHTR. 7. Disadvantages of VHTR. And the last one is the comparison between simple nuclear reactor and VHTR. Okay, this is the first things that I will discuss, which is what is simple nuclear reactor. A nuclear reactor, also known as an atomic pile, is a device that is used to start and control nuclear chain reaction or nuclear fusion processes. Nuclear reactors are used to generate electricity in nuclear power station and for nuclear marine propulsion. Okay, let's proceed to the next session, which is what is VHTR. VHTR is the very high temperature reactor. It's a nuclear reactor with a graphite moderator and a one through uranium fuel cycle that employs a one through uranium fuel cycle. The VHTR can produce from only heat by using thermochemical iodine-sulfur process or from heat water natural gas by applying the steam reformer technology to core outlet temperatures greater than about 100 degrees Celsius. This is the schematic mechanism of VHTR that contains 7 elements in it, which is a fuel element, reactor vessel, spent fuel, helium, steam generator, new fuel and containment structure. After that, we proceed to types of VHTR reactor core. First reactor core is pebble bed reactor. A graphite moderated gas-cooled nuclear reactor. The pebble bed reactor is a design. It is a very high temperature reactor, one of the 6 nuclear reactor classes included in the generation Ford plant. Pebble reactors are made of spherical fuel components known as pebbles. The second reactor core is prismatic block reactor. The prismatic block reactor is a prismatic block core architecture that stacks hexagonal graphite blocks to fit inside a cylindrical pressure vessel. Fuel is stored in the form of pebbles in a cylindrical pressure tank similar to a gumball machine. Okay, let's proceed to the next subtopic, which is nuclear design reactor. First, the element in nuclear reactor design, which is neutron moderator. The neutron moderator is graphite, although whether the reactor core is configured in graphite prismatic block or in graphite pebbles depend on the HTGR design. After that, nuclear fuel. The fuel used in HTGR is coated fuel particles, such as preserved fuel particles. Coated fuel particles have fuel kernels, usually made of uranium dioxide. However, uranium carbide or uranium oxycarbide are also possibilities. Okay, the next element in nuclear reactor design is coolant. First, helium. Helium has been the coolant used in the most HTGR to date, and the peak temperature and power depend on the reactor design. Helium is an inert gas, so it will generally not chemically react with any material. After that, the molten salt. The molten salt cooled variant, the LS-BHTR, similar to the advanced high temperature reactor design, use a liquid fluoride salt for cooling in a pebble core. Okay, let's proceed to how does VHTR work. A very high temperature reactor, VHTR, is a graphite moderated helium cooled reactor like GTMHR and PBMR. But the coolant temperature is significantly increased to 1000 degrees Celsius and beyond. This high temperature enables very high electric efficiency greater than 50% and open the door for industrial process heat production, especially for hydrogen production. In fact, a primary nuclear application for the VHTR is the hydrogen production. VHTR use triso fuel particles with small kernels of about 0.9 mm diameter in the form of UO2. The enrichment grade depends on the core design purpose. The VHTR design has been evolved from well-established gas-cooled reactor experiences. Okay, let's proceed to the next subtopic, which is advantages of VHTR. Efficient power generation. Most nuclear power plants currently in operation harness the thermal energy released during fission events by boiling water to create high pressure, high temperature steam. This steam is used to derive a steam turbine in a Rankine cycle whose efficiency is governed in part by the temperature of the steam at the turbine inlet. Second, efficient hydrogen production. The high coolant temperature also allows for efficient hydrogen production in a carbon-constrained world. Hydrogen presents an attractive option as an energy carrier. Hydrogen combustion does not produce carbon dioxide, and hydrogen is 3 times as energy dense as gasoline. Okay, let's proceed to disadvantages of VHTR. The high operating temperature in a VHTR causes helium impurities to be aggravated. In order to avoid neutron poisoning, the accelerated core corrosion due to the helium impurities, a helium monitoring and purification system will be required. The Fort St. Brain reactor experienced problems with helium exfiltration. All turbo machinery will require magnetic bearings to prevent lubricant ingress. In addition, the turbine blade will have to be cooled, likely decreasing efficiency. Ceramic materials will likely need to be developed for the turbine. In short, the helium sealing system will be complex and expensive. Let's proceed to the comparison between simple reactor and VHTR. For the simple reactor, use water as coolant. For the VHTR, use helium as coolant. After that, commonly use light water as neutral moderator in simple reactor, but in VHTR, commonly use graphite as neutral moderator. The last one, reactor use uranium for nuclear fuel. The uranium is processed into small ceramic pellets and stacked together into sealed metal tubes called fuel hoods for the simple reactor. For the HTR, reactor use coated fuel particles as nuclear fuel, such as triso fuel particles, usually made of uranium dioxide. Thanks for your attention and time. Have a nice day. Thank you.